This morning's live lecture video is over Lesson 10, Applications of Systems of Linear Equations. Ironically, the first two questions, you don't have to really use systems of linear equations. You're just answering the questions. So first question, a lab technician mixed a 530 milliliter solution of water and alcohol. If 3% of the solution is alcohol, how many milliliters of alcohol were used? And also, how many milliliters of water were used? Again, no systems of linear equations is required here. It's just a simple percent problem. So to find the amount of alcohol, we just multiply 3% or 0.03 times 530 milliliters. So when we do that, we get 15.9 milliliters. We also need to find the amount of water. To find the amount of water, just subtract 15.9 from 530. So 15.9 minus 530 is 514.1 milliliters. So no systems were required here, although this will help you with later questions involving mixtures. Question 2, we're not solving anything, we're just getting each expression. If the rate of the boat in still water is 31 miles per hour, and the rate of the current of the river is x miles per hour, what is the rate of the boat in each case? Part A, the boat is going upstream. That means you're losing speed. That's represented by the expression 31 minus x. Part B, the boat is going downstream. So if you're going downstream, that means you are gaining speed. Gaining means addition. So our expression for part B is 31 plus x. And this problem too will also help us with a future rate problem. Let's look at the next word problem from our handout. Hold on just a minute. All right, next question. Basketball team played 51 games. They won 19 more than they lost. How many games did they win? How many games did they lose? Let's use this sentence to build our first equation. W stands for the amount of games they won. And they won 19 more than they lost. L represents lost games. Our first equation in our system is W equal to L plus 19. Second equation is the number of games won plus the number of games lost equal the total 51 games. So W plus L equal to 51 is the second equation. Since we have a letter by itself, let's use substitution. So replace the second W with L plus 19. And that gives us L plus 19 plus L equal to 51. Combine the L's, giving us 2L plus 19 equal to 51. Subtract 19 from both sides. Giving us 2L equal to 32. And divide both sides by 2. So the answer to the second question is the team lost 16 games. Now we need to find the amount of games, how many games they won. I'm using the first equation and replace L with 16. So 16 plus 19 is 35. So they won 35 games. Add your amounts together, you should get 51 total. Next question is a geometry one. The perimeter of a standard size rug is 44 feet. The length is 2 feet longer than the width. Find the dimensions. Use this second sentence to set up your first equation. The length L is 2 feet longer, which means plus 2, than the width W. L equal to W plus 2 is our first equation. To come up with the second equation, use the perimeter formula for a rectangle, and that is P equal to 2L plus 2W, in which the perimeter, or P, is given as 44. Again, because we have a letter by itself, we can use substitution. So in the second equation, replace L with the expression W plus 2. And we get 44 equal to 2 times W plus 2 plus 2W. And just solve for W. So we have 2W plus 4 plus 2W. Combine the W's to get 4W. And subtract 4 from both sides to isolate 4W. Leaving us with 40 equal to 4W. Now, when you divide both sides of our equation by 4, we get 10 feet for the width. We need to find the length. Use the first equation in our system. And just replace W with 10. So our length is 12 feet. Our next question is also a geometry problem involving angles. Find the measures of the angles marked X and Y. Remember that the sum of the measures of the angles of a triangle is 180 degrees. So let's use that information to set up our first equation. Sum of all the measures of the triangle, or X plus Y. And y'all know anytime you see a box, that means 90 degrees or right angle, plus 90 equal to 180. Part 2, supplementary angles have a sum of 180 degrees. These two angles here that form a line are supplementary. So our second equation is 2x plus 35 plus y equal to 180. To solve this system, we need to move our integers to the right-hand sides. For our first equation, we'll subtract 90 from each side and get x plus y equal to 90. Our second equation, subtract 35 from both sides. And that gives us 2x plus y equal to 145. At this point, use any methods you prefer. I'm using the elimination method, and it's probably easier to try and get rid of the y's. But to get rid of the y's, we must have opposite signs. So multiply the first equation by -1. The second equation stays like it is, and our first equation is now -x minus 1y, or minus y, equal to -90. Now we can go ahead and cancel out the y's. So when we cancel out the y's and then combine everything that's left, we get x equal to 55 degrees. Actually, it's not degrees, I'm sorry. It's just 55. So to find our first angle measurement, actually it is 55 degrees, I'm sorry. Now to find the second angle measurement, you can pick any equation in your system to find the other angle. I'm using x plus y equal to 90. And in place of x, plug in 55. And you can either subtract 55 from both sides or do the addition mentally. However you figure it out, the second angle measurement is 35 degrees. Let's look at the next problem. Give me just a second to copy and paste it. Our next question is a mixture problem. Cornmeal is 6% protein. Soybean meal is 10% protein. How many pounds of each should be mixed together in order to get a 240-pound mixture that is 8% protein? Let X equal to the cornmeal and Y equal to the soybean meal. You can create a table, but here it wouldn't be necessary. Our first equation in our system is the total pounds of each meal that we have. So cornmeal plus soybean meal, we have 240 total pounds. Now, our second equation is just like the first, but we're introducing the percentages. So 6% for cornmeal, or 0.06x. Soybean is 10% protein, or 0.10y. And we need a mixture that is 8% protein. So you multiply 240 by 8%, or 0.08. Now, when we multiply those two numbers together, we get 19.2. Now, you can leave the decimal points in, or what I'm going to do is take them out. And to take them out, we need to move each decimal point 2 places to the right to change each decimal to a whole number. So our new equation, second equation, is 6x plus 10y equal to 1920. Scoot over the first equation. You can use substitution or elimination. I'm using elimination method. And I'm going to try and get rid of the y's. In order to cancel out the y's, our first y must have a negative 10 in front of it. To get that value, just simply multiply your first equation, your entire first equation, by negative 10. So we have negative 10x minus 10y equal to 240 times negative 10. That gives us negative 2400. Now we can cancel out the y's. Whatever's remaining combined together. So 6x minus 10x is negative 4x, equal to 1920 minus 2400. And that gives us negative 480. Divide both sides by negative 4. X is equal to 120 pounds. That's the amount of cornmeal that's needed. To find the amount of soybean needed for our mixture, you can either plug in X into any of your equations or just mentally figure it out. We need a total of 240 pounds, and cornmeal is already 120 pounds. So we need 120 pounds of the soybean meal to get our desired mixture. The next few questions, actually, the next question is a rate problem. So let's take a look at it. Okay, in his motorboat, Bill Rudberg travels upstream at top speed at his favorite fishing spot, a distance of 48 miles in 2 hours. Returning, he finds that the trip downstream, still at top speed, only takes 1.5 hours. Find the rate of Bill's boat and the speed of the current. Let x equal to the rate of the boat in still water and y equal to the rate of the current. Our table is already completed for us, but let me explain how my math lab got each rate. X minus y for upstream. X is Bill's rate of his boat. And because he's going upstream, he's going against the current. That means he's losing or subtracting speed. Downstream is the expression x plus y. And since Bill is going downstream with the current, he's adding or gaining speed. So that's why it's plus y there. Now the distance is 48 both trips, and the time going downstream is 1.5 hours. Rate times time equal to distance is the formula we'll be using to build our system. Okay, so upstream, the rate times the time, or x minus y times 2, is equal to the distance 48. And downstream, the rate is x plus y times the time, 1.5 hours, also equal to the same distance, 48. To make this system a lot easier to solve, in the first equation, divide both sides by 2. Our new first equation is x minus y equal to 24. Do the same thing with the second equation. Divide both sides by 1.5. Our new equation there is x plus y equal to 32. Right away, you can cancel out the y's because they're the same term and have opposite signs. So they are gone. Combine what's left over, giving us 2x equal to 56. Let's divide both sides by 2. X is equal to 28 miles per hour. This speed or rate represents Bill's speed. Now, to find the rate of the current, you can use any equation up here. I'm going to use this equation, and you can just mentally figure it out. If Bill's rate is 28, and we need a total of 32, then that leaves the rate of the current to be 4 miles per hour. So that's the rate of the current. This word problem is a real life application, meaning you should get answers that make sense. So if you get an answer that is not logical, go back, check your setup, check your signs, make sure they're all correct. The next question is also a mixture problem. I'm sorry, the last question was not a mixture problem, sorry. Uh, what I meant to say is this next question also involves a table, and we're mixing different amounts of candy. How many pounds of candy that sells for 91 cents per pound must be mixed with candy that sells for $1.39 per pound to obtain 6 pounds of a mixture that should sell for 99 cents per pound? Our table is already set up for us. X is the 91 cents and Y is the $1.39 candy. Let's use the table to build our system of equations. Our first equation is how much candy we have. So the 91-cent candy plus the $1.39 candy, we have 6 pounds total. Now, if you use a table to get the third column, you just go crossways and multiply. So we have 0.91x and 1.39y, and then 6 times 0.99. So that's our second equation with the actual dollar amounts. And all we did to get the second equation is just like the first equation, but this time around we introduced the dollar amounts. Now I'm going ahead and multiplying 6 times 0.99 to give us 5.94. Now you can leave the decimals in or you can get rid of them like I'm about to. To change each decimal into a whole number, just move each decimal point 2 places to the right. So our first equation bring up, and our second equation is 91x plus 139y equal to 594. At this point, solve by whatever method you prefer. I'm using elimination again. This time around, I want to eliminate the x's. To eliminate the x's, that number in front of the first x must be negative 91. So that's what we're going to multiply the entire first equation by. So when we do that, we get negative 91x minus 91y equal to 91 times 6. That gives us negative 546. Now we can eliminate the x's. Cross those out and combine everything that's left over. When we do that, we're left with 48y equal to 48. Well, our y value, when we divide both sides by 48, is equal to exactly 1 pound. No need to plug this amount back into one of your equations because you already know you need 6 pounds total. By the way, this answer represents the $1.39 pound offering of candy. The 91-cent pound offering of candy is just 5 more. So X is equal to 5 pounds. Let's look at our final question in today's lecture. Let me copy and paste it to our whiteboard. Tickets of a program at college cost $6 for general admission or $5 with a student ID. Let's stop here and label our X and Y. Our X is general admission, and our Y is with ID. If 181 people paid to see a performance and $977 was collected, how many of each type of ticket were sold? Let's use this information to build our system of linear equations. The first equation is the number of people. So the number of general admission plus the number with student ID totals 181. Our second equation is just like the first, but we're introducing the dollar amounts. So for general admission, it's $6 per ticket or 6X. Student ID is $5 per ticket or 5Y. And there was $977 collected. We have our system ready to solve. I'm using the elimination method, and it does not matter which letter you choose to eliminate, it will be about the same amount of work. I'm eliminating the X's. To eliminate the X terms, our first X must have a -6 in front of it. So to get that desired multiplier, multiply the entire first equation by -6. So that gives us -6x minus 6y equal to -1086. Scoot over your second equation. Now we can cancel out the 6x's. Combine what's left. So what's left is -1y equal to -109. And we'll divide both sides by -1. That gives us exactly 109 tickets. That represents the ones who bought the tickets with a student ID. Now we need to go back and find how many were general admission. Well, since we need, 180 was the total amount of tickets sold. And out of that 181, 109 were ID, student ID. So just subtract 109 from 181 to get the general admission. So there were 72 general admission tickets bought. This concludes today's live WebEx over Lesson 10, Applications of Systems of Linear Equations. Once this video is done processing, I will share it in Blackboard in the announcements.